Good afternoon. My name is Fernanda Cristina Poscai. I am a medicine student from Brazil, and today I will say a little about a neuroprotective drug, the NMDA antagonist to treat traumatic brain injury. Here is my last meta-analysis about animal studies using these substances to treat traumatic brain injury. Here is my background. This is a very important condition called traumatic brain injury, causes a lot of mortality and morbidity between people if less than 45 years old. So it's a great healthcare problem because it's very expensive to treat. These people will have a decreased quality of life and all these conditions. And here I will explain about the pathophysiology of the use of these drugs and how the glutamate acts, provoking the secondary injury. In traumatic brain injury, we have two mechanisms of lesions. We have the first primary lesion. The primary lesion is caused directly to mechanical forces, and this is the impact, the hemorrhage, the damage directly to the tissue. And the secondary injury is caused by, how I can explain exactly, cellular mechanisms of actions. By example, the glutamate. How I can say it exactly, a heavy impact causes a glutamate release. And the glutamate is a very important neurotransmitter, and this neurotransmitter also can cause neurotoxicity. This neurotoxicity is caused by this glutamate opening calcium and sodium channels, and this calcium influx entering inside in the cell, and in the cell, this calcium influx can produce edema and can cause neuronal death. Principally cause it activates proteases, cause oxidative stress, and also activates microglia. And so it's the mechanism it happens after the initial injury. So these people can have a neurocytotoxicity and can cause a cytotoxic edema. So the NMDA antagonists try to inhibit it. Let me here. This is the format of NMDA receptor. It's formed by 4 subunits, and these subunits are causing, how can I explain? It's block the influx of calcium and sodium, and the NMDA antagonists block the flux. By example, some NMDA antagonists are magnesium, ketamine, are memantine, amantadine, are very known drugs. These very known drugs are advantageous to us because we already know these pharmacological effects. We know the pharmacodynamics of these drugs. By example, ketamine is very used in anesthetics. Memantine is very used in Alzheimer's disease. Are safe drugs to people who use these drugs continually. So if a people use it in an event which is traumatic brain injury, it's supposed that these people wouldn't have a serious adverse effect. And here is the negative side of the use of NMDA antagonists. By example, the PCP-related agents, by example, ketamine, tilatamine, red was related to vacuolizations found inside the cell. And it stopped the use of these agents in researches a time ago caused it. But now, with more technology and ultrastructural examination, revealed these vacuoles disappear automatically after some time. And these vacuoles are caused by intracellular swelling compartments, by example, endoplasmatic reticulum and mitochondria. So it's not a irreversible lesion. It's reversible and is not registered about this condition happening in other NMDA antagonists, just as this. MK8 H1, and tyletamine and ketamine. Here is the pathway of NMDA antagonists active between the cell. And here is my review question. Here is also my Prospero register, if someone wants to read after the rule protocol. And my sources of research was Medline, PubMed, Linux, and Genbase. The keywords was very specific. I used mesh terms about NMDA antagonists, and I used also the name of the most common drugs, because most of these drugs are not known most by his NMDA antagonist properties. By example, dexanabidiol. Dexanabidiol is more known to be a cannabidiol, not an NMDA antagonist. So I put in the search his proper name. The inclusion criteria was rodents. The intervention, I select every intervention related to traumatic brain injury, all type of doses, all type of frequency, time of start of admission, route of administration. And the outcomes, the primary outcome I finished now is the brain edema. The brain edema was measured by specific tissue gravity and brain content water percentage. And to calculate it in a meta-analysis, I utilized the standard mean difference. Yeah, another thing is very important to say, studies where cerebral edema was only measured 5 days after lesion was excluded in this meta-analysis, because it is reduced the sensibility of the brain edema, according to previous studies, of course. The data extraction strategy was that. So a lot of the information was in graphs, so I used the Ebplot digitalizer to extract this information. And here's the results. How you can see in both random effects model and fixed effect model, the meta-analysis is significative and is, how you can explain, it's significant difference and was a reduction in brain edema. The only problem is the high heterogeneity. The heterogeneity is significant, principally because the various kinds of studies, different routes of administration, different drugs, different times to start the administration of drug, different times to evaluate the results. Here is the forecast. Here is another meta-analysis I would compare. It's not my paper, it's a previous paper about the antagonists. I will talk about this. But returning to my meta-analysis, in this work, this work isn't going yet. The protocol is registered, we have this meta-analysis, but we intend to do more analysis indeed. So some sub-analysis we pretend to evaluate NCA's scale, because it's not useful just to reduce the brain edema. You have to improve the quality of life of these people after the trauma. And by example, we have to analyze how the time of to start the drug influence the outcome. So yet we have a lot of things to analyze in this study. In the end, I have a Cochrane submitted protocol. It's in editorial phase, but the initial proposal was accepted by Cochrane. This is about human studies, about the use of NMDA antagonists. And here's the previous studies about NMDA antagonists was if specific drugs, MK. MK was used in this meta-analysis in a lot of kinds of injuries, not traumatic injuries, was hemorrhage, ischemic, strokes provoked in rats, was all kinds of injuries in rats, and was also significant. So probably the use of the antagonists are a promising therapy to future. So I guess. Thank you, everyone. This is my contact. If anyone has a cash, I need to see.